Okay. I'm actually gonna up my bit rate. Wait. Okay. So we're now on YouTube. I think I'm gonna I think we can change this live. Okay. And I want to see a preview here though. I think this is the wrong stream. Hold on. Okay. Fantastic. Okay, so now that we're done with this. Okay, what's the delay like? The delay is actually kind of high. Look at this, because this happened like Can I change that live? Probably not. Probably not. Dude, what is this even for? This thing needs to be way smaller. Can I put it up there? Oh, nice. That's perfect. Okay. All right, so let's get to work. Okay. So that's the front, this is the back, so this is where we're going to be doing it. So on the top plate, just say it's here. Creating a sketch and the first thing we need to do is figure out the footprint of this thing. So we kind of want to know I wonder if that's possible. Which sketch is it? Is it? So let's cancel this. Okay, if we look at this sketch, we want to draw a line from here to here. And then we want to make this nerf diameter. And then we want to make this, the problem is now this has this freedom here. So this point and this point we want to be, so wait, let's undo this. We select this point and this point and we make them horizontal. Okay. So basically what we're saying is that the ball, and then let's draw another line here. And this is also Q for construction. And we want to make sure that it's on this and it's on this. And then we want to, is this constrained? It should be constrained. Oops. It doesn't look right though. It just looks kind of grainy. Oh no, that's just the dottedness. Okay, so this is 48 or 46. I can't tell. 46. So if we were to and then if we look at it directly from the top here, yeah, this is equal. I kind of have a feeling that we, how far apart were they in the original design? They were, I think they were actually more than this. Because these are, what, 50 apart? It's probably 50 apart. Oh, wait. Yeah, it's 50. So if we open up... Can I just change it in here? So that left click... I never use this thing. I never use that. Wait, why does this look... Oh, wait, didn't I just drill holes? I'm pretty sure I just drilled new holes. But in any case, what is the distance? And it's so annoying because if you click two circles, it gives you min distance instead of center distance. That's one of my favorite new features in Onshape is like... But anyways, let's open this up and just look at the sketch. So we do open. And then we actually want to... Yeah, it's this. Oh, and we're going to have to model the solenoid. I could probably import it as a step file, actually. I'll probably just do that because, like... Well, maybe we can look and see if there's sheet metal or whatever, but... So I guess feeder and solenoid. Okay, so what we want to do is we probably want to look at... Oh yeah, this part was weird because we started off with the... I'm pretty sure this is 50. Yeah, that's 50. So we might just have to drill more holes. I might just add... Maybe I'll just add more holes. Because if that's 50 apart, then we need... Well, sort of like 24 more. We kind of need like a 75 because if we're gonna be consistent about this requirement that mounting holes need some ratio, and that ratio is 1 of distance from the edge. So since most likely nobody's really following along, we have this variable called mounting hole edge distance ratio. And what that's saying is if you have a mounting hole that's 6 millimeters in diameter, then you want to place it this ratio away from the edge. So yeah, that's where we're getting for each side we need 6 on one side and 6 on the other side to the stand. And that gives us, well, really no, it's going to be 3 times. It's going to be 18, it's going to be 36. It's going to be 50 plus 36. So let's just I just want to make a new part. And this is just going to be, oh wait, we have this. So let's delete this. We can We can just do this later. I don't really care about this. So fine, I'm just gonna do a new part studio so that I don't have to worry about this. Okay, so what we want is a rectangle like this. And then this formula is going to be 2 times wall plus 2 times 3 times mount times M6 hole plus solenoid width plus 1 or something. I don't know. I think it was 2 actually. Let's see. This face to here is 40, but I think if we import the solenoid, I think the distance was 39. So yeah, we only need 1. Okay, so plus 1. So we're going to call that solenoid clearance. Okay, so then what we do in onshape, which is so great, is that we can put a dimension on here, but what we say is feeder width, and this is going to be 2 times wall plus 2 times 3 times M6 hole plus solenoid. Oh, you can't define a new one in here. So wait, let's just do 39 plus 1. And then these have to be freaking... Okay, but what we need... 87. Yeah. And then we need to place the holes. And then the thing is, 87, the problem is if... I think what we're going to have to do is we're going to have to notch it. We're going to have to make this height less, and then it sort of sticks out. I forget exactly what face it printed on, but we might be able to get away with it. But we need it to stick out because the issue is we need to put it here, but it can't hit the flywheels. So the flywheels, we have like 46. So we need like a small inner channel. And then we're going to need holes way out here, but we're also going to need to know... Right, okay, so what we also need to calculate is, remember that hole, that mounting hole, top plate mounting holes need to be less than 100 millimeters to the center. Because otherwise they collide with the pillars. Or more specifically, the hex nuts that go on the mounting holes will collide. Great. So I'm pretty sure I'm going to add some more holes because if we look at what's printing right now, I already printed something that's specific to those holes. So I think the better option is just to add more. Oh, I actually closed it. Oops. Okay. So anyways, and I'll probably close it again. Okay. Well, in any case, let's just keep going. So what did I call it? Oh, it's just this. Just call it solenoid. It is the feeder. But so this is going to be the feeder width. And then what we wanted to do was let's just get some of these solenoid things down. This is the only one we really need. We should come up with the this name, the like colloquial name, is actually We'll call this actual width. And then this is just going to be solenoid actual width plus solenoid width clearance. And then this is what we use. And so then we can go into the solenoid holder and we can fix this formula to be, oh wait, we have to just change, oh, but then we put it in here. See, that's the annoying thing, is actually what we don't want is that. So I'm going to copy this, I'm going to delete this, then I'm going to go to my variable studio. I hate that it always brings you to the top. I feel like that's so silly. So then this is going to be solenoid, oh wait, feeder width. This is going to be plus solenoid width. Okay. So now, oh yeah, so here's what we can, oh, I don't have the preview. But I ended up printing that top bracket, so wait. Okay, never mind. And then this, what did we actually use to determine that? And the thing is, okay, well, that's all right. When we do the joint, we can do the test of whether or not it's this is 107. How did we come up with that? Wow, great name, W. Okay, let me just lock in. I'm gonna change my pants. I'm getting hot. So this was 102. So oh yeah, okay, wait. So the solenoid length is 64. So let's just define that. I'm just gonna use actual to mean like this is a dimension that is reported by the manufacturer or something, but basically an unclearanced value. And the height there is 32. Oh, but the problem is we're gonna actually need to raise this up slightly more because, oh, and you know what? Well, maybe we can put them here. I was trying to think about how we're gonna deal with the hopper. The hopper is gonna be tough. That's gonna be a whole new thing that we have to iterate on. Okay, well, what I want to build actually is I just want to build this part. I think that I should build this first in onshape just to get going. Which Okay, so let's just start taking some dimensions. So what is determining this dimension? This was 40, right? 43. So why though? This extrusion? No, wait, there was this extrusion. No, there was this extrusion. Yeah, it was this extrusion. No. There was one that, okay, wait, if we just play it back. Oops. Why isn't it updating? Oh, there we go. This. We moved this 8 back, and we moved it 8 back because let me get my calipers and the solenoid. I'm pretty sure I moved it back 8. I forget what that dimension actually is. Okay. Okay. Excuse me. Okay, so what that 8 millimeters is coming from actually is if you look at the assembly, it's the distance to make this plunger not hold the ball up, because basically if that comes out of the loft, like it comes out a little bit, but I don't think it's enough where it actually causes an issue. I actually, yeah, okay, so what does that mean? That means that we need to make, all right, so then I'm sort of okay with you make a square, you draw the circle in the square, and then you extrude that, because then you don't have to, well, maybe we'll do it as one sketch. So what that means is in this, okay, so we actually want to make this, so we're going to start with the square that's 50 by 50. So that is going to be the feeder outer wall to outer wall. So okay, and so this, we take 2 times wall plus solenoid width. So we're going to delete this. This is going to be 2 times wall plus solenoid width. And then we're going to add this. It's so funny how, like, sub-expressions... Wait, what happened here? Bro. Okay. So this square is going to be feeder outer wall width, and then, but it's not going to be 50 by 50, right? Why would it be 50 by 50? I understand that the distance from here to here is 40. And then this is 43. And this is what, 32? So that's solenoid height. And the reason, okay. So that dimension makes sense. The reason why we want it to be solenoid height is because then the plunger will be in the middle. So that checks out. Okay, and then this dimension is the 40, so that's going to be 50, and then this is a little confusing. Because 50 might not make sense. But all right, let's just try 50, 50, and so this is going to be feed outer wall. And then this is also the same. And then it extrudes by solenoid height over 2. Or no, just solenoid height. Okay, cool. So we're here. We're going to undo this sketch. We don't need any of this. Or, wait. Let's just redo everything and then just delete this. Okay. So this is going to be... Oops. This is going to be feed outer wall width. This is going to be the same. For no reason. It's kind of janky, but can we just click on this? Why can't we click on that? That's so weird. In Fusion, you can just do it, but whatever. Okay, so then we're going to draw a circle. Okay, wait, then we're going to extrude this by solenoid height. Solenoid actual height. Right, now we're going to draw a sketch on here, and we're going to draw a sketch on there, and we're going to do the loft. So here we want to draw a circle, and So if we go back to that first sketch, what do we make that very first width? Oh, I can't tell which was which. This was the 40 and this was 35. I don't know why we made it 35. Is there a reason for that? Okay, fine. But let me just draw a line here. So this is to 35. And so if the circle was in the center of that, then that means that it's at 17 and a half over, which means it's going to be, okay, so we could just define it in terms of that. So if we take this to here, this is going to be, okay, and so what we want to do is make a variable feeder hold nerf diameter plus, oh wait, so we'll just do feeder nerf clearance, and it's going to be it's going to be defined in terms of, well, that's kind of janky, but yeah, we could just do 25 minus feeder hole. Oh wait, sorry, 25 millimeters minus nerf, and then this is, I actually like the fact that you have to order these yourself, but I wish that it was a little bit better. Okay, so feeder hole diameter. Dude, who's Bob Simple? Yes. Yes, friendship with Twitch is over. I feel like Twitch is I feel like nobody shows up to the Twitch stream. Like Twitch's discoverability is really low, but also I think the number of users that Twitch has is just really low. So I feel like this is probably a better place. So this diameter is going to be feed hole diameter. Wait, Ole, is that you? Are you Bob Simple? Gotta get the sun out of my face. Okay. And then this one, okay, so we finish this sketch. Then we draw a sketch on here. Normal, okay, then we're going to draw, I don't know why I don't get midpoints. I find that so weird. If I'm in this sketch and this is a rectangle, why can't I just draw? Okay. Okay. So now we have this point, right? So now I can make a circle that's there. This is going to be, yeah, this is going to be, what the hell? Feed hole diameter. I wonder if these recommendations are based off of usage. I really hope so. That would be cool. It would actually be cool to know how many usages of each variable there are in the CAD. Okay, so then we have to do the line thing. Okay, so let's just do the loft. This 50 millimeter diameter is super sus. Okay, let's just do the loft. I mean, we can't keep Okay, so this sketch is done. Now we want to do Alt-C plane, and we want to make it a mid-plane. It's not this. It's this and this. Now we're going to draw a sketch on, oops. How do you get this plane? It hides all of them. There we go. So now we Shift S, N for normal. Okay, and now what we want to do is we want to take this circle and this circle, and we click U for use. We also want to click this point and do use. So now we have those. Now we're going to draw two lines, and they're construction lines because they're not actual. And we want to make this perpendicular or vertical, and it doesn't really matter how far it goes out. And then another one here. Okay, and now what we want to do is we want to go to Alt-C tangent arc, and we want to select this point and this point. And then this should be fully constrained, but it actually looks like there's kind of a hook on there. Oh wait, you know what? Let's try to redo it. If I do tangent arc, and I select this line and this line, there's kind of a hook there. But I want this and this. Oh wait. This. Hold on. I'm so confused. I want this point and this point to be coincident. Oh, there we go. Now it's fully constrained. Right? It still doesn't look right. I mean, that's definitely wrong. Okay, let's try it one more time. Tangent arc. You select this point and you select, or this line and that line. And you say that this point and this point are, or wait. So okay, that gives us tangency, but now we want coincidence. But then we don't. Is it just not possible? Maybe it's not possible. Is that true? I feel like that's not true at all. You can definitely have, if this is the center of the, is that just because? Wait, what we want is this point, and I think, can we project this point? Oh, but you know what? That's because, no, so what we would need to do in this sketch is we need to make it 16. That's where all my problems were coming from. So now, oh wow, and it resolved it. And this looks tangent. Okay, cool. So now what we can do is we can do Alt-C loft, and then we're going to make it remove. We're going to take this profile, and then we're going to take this path, and it's going to be there. And then if we just do this, oops, that didn't work. Let's see, why didn't that work? Is it because we don't have a merge scope? Merge with all? No. Profiles. These are the right profiles. Oh. How did I do it yesterday? Literally the exact same thing. Solid, remove, profiles, face 2, face 3. Oops. Okay, let's just clear this. Is there a doc string on this? What does this even mean? It makes no change. I'm so confused. What did I do wrong? Check profile order. Oh, why does profile order matter? That's strange. Okay. So now before we forget, let's we're gonna draw a sketch on here. We're gonna take this circle and we're gonna use it. Now we get this center point circle. Now we're gonna make this. And what we want to do is feeder. We want to define a variable called feeder feeder hole feeder hole. Do we want to define it as compression? I forget what I did. I think I actually tuned this a lot. And I'm pretty sure. Wait, let's go all the way to the front. And I'm pretty sure. Let's see. If I select this rim. Okay, wait. It's 22, but I'm pretty sure I updated it actually. Oh, no. 22. So it's only being compressed like 0.2. Oh man, I really wish I could let's see. What? Okay. How is the how are springs in terms of the force required to stretch them by a certain or yeah, I guess you can have springs that do compression too, right? Okay, so for springs that get compressed, how is it that they measure the force required? Because I'm guessing there's a graph that says for a given distance of compression, this is how much force is required to compress it that much. How do they measure that? Hooke's law is so stupid. Bro, it's not linear. Well, you know what? Maybe it's not stupid. Maybe these physicists are right. Should just treat everything like linearly.
Today, I'm going to introduce Intercom's valve spring tester. All racers know strong valve springs are crucial to get the most performance from any engine. The valve spring tester provides an accurate way to check the strength of valve, clutch, or any other small coil springs on a race car. This rugged field-proven product is...
Okay. Wait, I want to see the other one. I mean, this is exactly what you want.
2011 SEMA.
Hello everybody, I thought I would throw together a quick YouTube video about valve spring compression testing. Now this is in response to another video I watched on YouTube where a gentleman had a bathroom scale on his drill press and he's using that to check valve spring compression. I thought that was pretty neat, and so I commented on his video and gave him some credit. And someone else replied to my reply, tearing me apart, saying I didn't know what I was doing, I was going to oil down tracks all over the US, and you know, one of them doom and gloom guys. Anyways, so what I've done is a little bit better setup than the other gentleman had. I think he was only restoring an old Studebaker, I can't remember what. But all he was doing was checking to see if his valve springs were still good. And that's all I'm really doing on a stock application. Now, I guess I get that other guy's point. If you're doing a race application, high RPM, big cam stuff, of course you want to check your valve springs very carefully with proper equipment. There's a lot going on in the valve spring, a lot of pressure. They have a big job. They got a closing time, or all that power's going out the drain, and you know, what's the point of that? So anyways, but for backyard, garage rebuilders like me, you know, doing a re-ring, new bearings and gaskets on an engine, a lot of people just throw the springs back in, you know, and how do you really know if they're good? You squeeze them, look at them, how do you know if you got duds or not? There's a lot of valve spring compression testers out there, $100, $200 to get you one. There's some that work in a bench vise, I think they're hydraulic, I'm not sure. And then of course the pro ones are $1,000, $2,000, and obviously that's what you need to use in a race application. But for just a guy that wants to check to see if his valve springs are duds or not, I thought this would work good. So what I've got is a decent drill press, and this isn't a bathroom scale, it's more of a shipping scale or bulk produce scale. I've got it upside down, so there's a nice surface contact against the drill table. And then I've got a 1/4 inch plate sitting on the feet of the scale. Now I have to be a machinist, so I have some adjustable parallels, a dial indicator, caliper, stuff like that, a drill press, but that's not odd stuff for a backyard mechanic tap. So I figure anyone can do this. This plate was an offcut. They charged me $5 for it down at the scrapyard. But I mean, you might have something ready that'll work, or around the farm, or at home or whatever. So all this isn't really costing anything, and I think it's a reasonable result. This is an old valve. I mean, it's for my anvil, I guess you could call it. It's up in the chuck of the drill press. It's up all the way, so it can't slide or anything. I even have the bottom of the table jacked up with some jack stands, so it won't flex or anything like that. And I figured it can give us decent tests. Now, one of the complaints was, well, as you're pushing force against that scale, the scale's moving. So your measurement's out of whack. Well, it is moving, but my reference point
Okay, I am back, and what are we doing? I'm not watching this crap, dude. This is just like wasting my time. So, we got the loft done. Wait, this is the wrong thing. So now that we have this, what we want to do is we want to draw a sketch on here. I don't know how people are good at this. Okay. Okay, so what is that circle? Oh, you know what? No. We're not done with this. Oh, yeah. Okay, wait. You make a sketch on here, normal. Then you take this, you use it, then you make a circle here, and this is going to be 22. So we're going to say, we're going to make a parameter. Right. Okay, now I remember what I'm doing. It's going to be feeder compression, feeder nerf compression. And this is going to be 0.5. And so that means that feeder nerf feeder exit diameter is going to be nerf minus feeder nerf compression. And then the depth of it, I don't remember how much we actually extruded it by. So what feature is that? That's this. And we did a 2 millimeter. Okay, so then feeder exit notch depth. I'm just gonna make that 2. I like splitting up. You just sit here in a table and you define it, and then once you're in the sketch environment, you just have to remember the variable names, and I think it's really nice actually. Okay, so now here, all we need this is to be exit diameter, and then we're gonna take this profile and we're gonna extrude it by, so first off, it's gonna be an add. It's gonna be this way, and then this depth is going to be 2, but it's feeder exit notch depth. Okay, now if we look at it from in here, we see there's a small notch that prevents them from falling out. Okay, now we're ready for this. We're going to sketch, go to normal. Unfortunately, we don't get a freaking midpoint. I don't know why we don't get midpoints. But let's just do what we always do in Fusion 2. You just do this. And I wonder if there's a setting where you can just like, how do I just prevent, I don't know. Okay, now we get this point, and we want to draw a circle here, and then what we want is I wonder if we have parameters. Great, bro, great. That's sick. That's so sick. That's so sick, bro. Okay, so, I don't remember, but we honestly don't really need it. So we're just going to come in here, and we're going to say plunger hole diameter. Let's make it eater. And this is 10. So now we can come in here, make this solenoid plunger hole diameter. And we're going to take this and we're going to extrude it, and it's a remove, and it's up to next. Perfect. Okay, well, how do you just rotate 90 degrees? How do I just rotate 90 degrees to the how do I rotate 90 degrees in onshape? No. I meant my camera. No, I don't want the view cube. Wait. Wait, is that true? That doesn't rotate you at all. Or that, I just want to move so that this is like that. Okay, well, whatever. So now we're going to sketch on here. And we are going to draw... Oh. And then we're going to extrude this by the width. I'm not actually sure that 50 is right. Okay, but fine. So now we're going to take this profile, extrude this by... It's not the width, it's solenoid actual length. Right. Should I import the solenoid? I feel like this is too long. From this to here is 50. Okay, let's look at the actual part. This line to this line. That's just 43. And that's flush. So let's change this. So we need to go up to the very first sketch. And we just want to change that variable. Oh wait, no. We want to make a feeder block. And this needs to be feeder block. It needs to be feeder block length. Okay. So now I am going to just import the solenoid because that's going to speed things up a little bit. Did I ever post that solenoid on GrabCAD? I don't think I did. Okay, let's just, I'm gonna go open up solenoid. And we're gonna export a step file. Okay, now we're gonna go to GrabCAD. And it's gonna be logged out like usual. Oh, it's not. That's awesome. How do I upload? Where is it? Okay, and I want to go to Amazon. Wait, okay, wait. Let me just, here's what I'm gonna do. Aposar. So yeah, so all right, so now we have this. So we have the step file. So I'm gonna go import the step file. Oh, is it an import? Okay, so it imported. Wait, but these are also assembly files. Oh, yeah. So open up. Oh, and it just made a parts file. It's kind of goofy. Because now I have all this crap in here. Okay, wait. Can I select multiple tabs at once? Oops. No, so I have to move all of this crap over. I'm gonna undo that. If I undo, does it? It's not clear what undo does because I don't want to change anything here. But I do want to. Okay, I'm just gonna delete this. I'm gonna delete this. This I have not really figured out. So I'm going to go, just in case, I'm going to go all the way over here. Then I'm going to import it so that it doesn't import it at the top. But I'm also going to do it the other way. So import solenoid. Oh, but the thing is, we kind of, well, we kind of do want to put the motion in, but I'm just going to try this for now. Because all I want to do is project those little circles. We could redo this sketch too. Actually, that's a good question. I don't think yesterday we did any cases where you have this weird projection thing where you're projecting from a different part. And since you can't have okay, I know what's going on. Okay, so that's kind of what I wanted. Then it didn't open up a bunch of stuff. But so I'm going to make a new. They should have a file search thing. Do they? Oh, tab manager. Oh, that's great. And you probably make tab groups or something like that. You can filter. That's nice. Dude, that's so much nicer than Fusion. So whatever, but we don't really care about this. Is there a hotkey to get that open? Alt what? Alt T? Nice. But it doesn't automatically bring you to the search, which is what you want. But whatever. Enter to open. That's nice. What is this thing? I don't really get that. Okay. So we're now making a new assembly. And this assembly is going to be called this is going to be called the solenoid or feeder assembly. Okay, and so now we're going to just insert, and we want to insert the solenoid, and we want to insert the feeder. But is that what the feeder looks like? Oh, it's called solenoid holder. Okay, so now what we want to do is we want to join, or mate. Dude, I'm so stuck on that. Oh, wait, but what we wanted to do actually was this, and this are, oh, wait, but we have to do it first. Okay, so And then we made it. And then we need to... Perfect. Beautiful. That was really easy. Okay, but now what we want to do is we want to... So we don't need this. What we want to do is we want to take... so we're going to hide this part. I'm going to take this and use it. See, we can't... That's the thing. Maybe that's better, but maybe that stinks. Because... Okay, so we're going to call this the bottom of the solenoid, and we're going to just redo it, I guess. Let me just ask. I'm in onshape, and I'm in an assembly file, and in Fusion, since there's no distinction between a part studio and an assembly, I can take the mated or joined components, and then I can project some geometry from one of the components to the other component, and then use that to do something. But it doesn't seem like you can do that in onshape, really. How do you do it? How do you use geometry from another part? Okay. Derived in context editing. In your assembly, right click on the part and select edit in context. Okay, let's try it. So I want to take this part and I'm going to do edit in context. And so then I want to, okay. Okay. This is exactly what I wanted. So I want to hide the whole part. I want to select this. I want to use it. Use it. Come on. Can I do that? You can't. You can't. Did I select the wrong thing? You can't use it? Okay, but what you can do, I guess, is you just... Do you even get these circles? Oh, wait. Do you have to be in... Oh, you have to be in... Okay, so what we're going to do is we're going to take this. We're going to sketch assembly context. Okay, now we're going to hide this part. We're going to select this. Oh, wait. Let's undo. I'm going to delete this sketch because I didn't know what was selected. I'm going to take this, sketch on it. Wait, but where did my thing go? Oh, I closed the assembly context. Okay, wait. We need to go back. So feeder assembly. We select this part. We go to... First off, this is the part that we want to fix. Anyways, we want to edit in context. Then we want to sketch on here. Then we want to hide this part. I'm going to click... Wait, I just said hide the part. When we select this and use it. Oh, baby. Wait, but we don't get... Okay, we actually have to select the specific... All right, perfect. So now we can just... I wonder if you can invert a selection. Whatever. We're going to take this, this, and then can we offset? You can't offset that because... so we just need to do this. And these are... those are 2.5. What did we make them before? We made them 2.5. Oh, wait, no, that's on the actual thing. Yeah, there's no way we did that. We probably made them 3, maybe 3.2. We made them 4.4. Oh, you know what? I'm just going to use that. Okay, so we're going to just make them M4. So oh, wait. I got to get fast, man. I'm doing stupid stuff. Is it in this or is it in this? Oh, wait, so you know what we could do? I wonder if we could do this. All right, so let's do this one more time just to lock it down. We could leave that. But so we're going to go back to the feeder assembly. I'm going to right click this, edit in context. We're going to sketch on here. We are going to hide the part. We're going to press P for, no, we're going to hide the part. We are going to select this. Wait, no, we're not going to select that. We don't need that. What we're going to try to do is, okay. But if you delete this, yeah, so no. So, okay. So you can't just select the center points, but that's fine. Okay, so now we want to enable this part. We want to draw. Okay. And then can we hide this? How do we, oh wait. Oh, and that's so sick. And then we're going to take it, then we're going to do a mirror. Wait, first we need plane. Mid plane. Select this, select that. I thought we have a mid plane. I'm pretty sure we have a mid plane. Yeah, we do. Mirror, feature mirror, select this, then we select the mirror plane to be Pro. I wish you could select it from in here. You can. Nice. Gorgeous. We have done it. We have done it. So now we need to calculate the height. And then we can finally do the legs. My print is probably done. I don't care. I don't care. But just stay focused, bro. So so what is it that we need to do? We need to look at top plate. Ooh, this is yeah. What we want to look is top assembly. Hello? What? Did we just never do anything with this? No, there's parts in here. Is everything... I'm so confused. That's so... Okay, that's just bugged. That was weird, man. Okay, so now... we are going to do something. And that something is figure out... okay, so... can you make that a measured quantity? I thought there was a button there to make this a measured quantity. Wow, look at all this. This is awesome. Okay, wait, so let's just make a variable for that. So, yeah, that'd be so cool is if it could figure it out. So, because that's going to be... oh, but there's a bunch of random stuff in there, right? Well, we can do our best. So it's going to be wall. Okay, so this is going to be top plate to bottom flywheel. And that's going to be equal to wall plus bracket height, bracket height, plus that D35, 36 bracket, bracket height, which is 3. That's 3. This is 5. Bracket height, I don't remember what we set that to, but it'll be a good exercise to go in the timeline and figure out what variable it's set to, because it should be very easy. And then plus BLDC. Yeah, we should add a measured quantity that if we look at this part and we just take this face to this face, okay, so let's just make a variable for that. BLDC height is 32. And this is the height, the length between the flat parts. So excluding shaft and shaft notch. Okay, so then we'll just add a couple more. I mean, it's probably not all that necessary, but we could look at this. Okay, so the notch diameter is and the notch height is okay, notch height is 4. Do we even care about that? Pee. Okay. So, okay, so the measured quantity is going to be the following. We're going to take the flywheel assembly, and we are going to compute. So, we're going to take this face, then we're going to hide this part, then we're going to select this face. And the distance. Okay, so that we're just going to make a parameter. So, okay, so top BLDC to bottom flywheel. This is 2. Great. So now, top plate to bottom flywheel is going to be wall plus, what is the bracket? Is there a bottom plate arc angle? No. It's called yaw only or something. Yaw only stand height. Can I rename this to be yaw only stand height is also going to be called wait, all right, I'll leave it as is. So this is going to be called yaw only stand height. Okay. Wait, but that's dude, why does it always mess that up? I feel like it's always okay, but this isn't quite it because this is going to be plus the the I'm almost positive that doesn't have a dude, why is this okay, wait. This is what we really need. Wall plus yaw only stand height plus BLDC mounting bracket depth plus top BLDC plus BLDC height. And I'm pretty sure that's right. Wait, 62. Let's check it. So full assembly. Here to here. 57. Okay, so here to here is 5. Here to here is 20. Oh, the stand height. Okay. That actually checks out. So we just need to remove wall. Dude, this is so bad. This little text editor is so bad. Okay, so that's correct now, though. So that's great. So, and what we want, I think, is, so we don't need to refer to anything else, but I think the idea is that we want the, okay, well, let's just start with the simplest thing, which is we want the middle of the flywheel to be, like, if you draw a plane at the middle of the flywheel, you want the middle of the feeder's exit hole to intersect that, the center of the exit hole. which means that the total height to the exit hole should be this plus flywheel depth over 2. Okay, so so then this plus flywheel depth over 2 is equal to the exit hole center height, which means that the extrusion amount is going to be this minus solenoid height over 2, which is 16. That's the 16. Okay, so we're going to go to solenoid holder. We're going to draw a sketch on here. I'm going to click G. And this is where we could make this not full distance. So this is definitely a wall. Oh, we don't. Okay. It takes a while. You see it turn blue and then it turns black once it's solved. So it's actually, it's fine. But so then this is going to be a variable. So we're going to extrude this and we are going to name it this is going to be the bottom feeder. I like that. Top plate to bottom feeder. Okay. Oh, wait, we need to do this. Let me make a new variable. And this is going to be, it's going to be the, oh yeah, see, I don't like doing this because we actually want to, okay, we actually want to go into here. Top plate to bottom feeder. I believe it should just be top plate to bottom flywheel minus solenoid height over 2. I'm pretty sure that's right. So now we're just going to go back to solenoid holder and we are going to extrude this by top plate to bottom feeder. Why isn't it letting me? I'm so confused. What the hell? What? Bro, why doesn't it? It doesn't give me any information. I'm just going to refresh this page. I don't believe that's true. It thinks I'm in here, but I'm not. Oh, wait. Oh, it did it. It was just like lagging or something weird. Okay, so then we just draw a sketch on here. And then this is going to be 3 times M6 whole. Then we're gonna sketch on there, normal. Okay, now we want this to be in the middle, so we might as well just draw a construction midpoint line. And then we're gonna draw a circle. Okay, so now here's the real question, because we don't have a reference on which to calculate the so let's just say that we're butted up right against, so this face is right up against this. $68.6 in the midpoint of that on a plane the midpoint of this part intersects the center for sure. So what are we trying to figure out? We want to know the distance to these mounting holes, because they need to be less than 100, because otherwise they'll hit the pillars that support this thing. So what we need to know is we need to draw a carefully placed point out here. So what we want to know is, okay, I got it. So what we're going to do is we're going to use this, and we're going to draw a line from the center of this up. And now this distance is, it should be 60, I think this should be 60. Okay, so can we, I wish when you typed in numbers, it actually reverse searched all of your variables, because okay, there's nothing related to 68. So what I'm wondering is, so now we need to go back into, oh, you know what would be nice is just if we had a bunch of tabs, maybe. I don't know, because I keep trying to alt tab into it. That's the biggest thing to get over. So we want to look at top plate, and we sort of want to see the history. Okay, so this gives us a highlight of all of the features there. So let's just go, okay, so if we look at this sketch, right, so what determines this? Oh, it's, okay. Okay, so it's this plus this plus this. Oh, wait, so it's 3/2 though. So it's going to be 25 plus 3/2 of M6 whole. And that times 2. And let's just check that out. 2 times 25 plus 3/2 times 6.2 is 68.6. Perfect. That's exactly right. Okay, so that means that we can make a variable for that. And it should all work out. So this is going to be the yaw only bracket width. And this is going to be 2. Does this work? It's probably because, oh wait. Yeah, no, you have to do times. You have to be explicit about it. Which honestly most parsers do that, so I'm not even upset. So it's going to be 2 times 25 plus 3/2 times M6 whole. bro, I swear it's insane because onshape is so good, and yet this variable studio thing is so bad. Error regenerating. Could you make a worse error message? Any error message is error that's just error is like broken. Oh, see, it should parse it and be like, okay, here's where the problem is. Okay, so now we know that in solenoid holder, this is going to be yaw only bracket width over 2. So now, if we were to draw, let's say we draw a circle right here. Okay, first we're going to make this M6 hole. Dude, I love that they have like in League of Legends when you search up a character name, like M6, it just oh, it's not the same, but it's like pretty good. Okay, so we want this to here to be, oh wow, see, look at that. But I think there is also a, wait, so can we make it 100? No, we probably have to make it like, oh, I can never remember if the 100 is a cleared or uncleared value. Okay, so let's make it 95. And then what I want to know is the distance. That's shocking though, because when we look at this is 70. But that doesn't make sense. Were we even able to get those on there? Okay, well, it looks like it works, but I am suspicious of that. But so we also want to draw a construction circle of here, and this is going to be the big gear outer diameter. See how little room we have? Okay, if we keep this as it is, and let's add the hole here. So we're gonna just extrude this. Wait, what did we say that was actually? Can we go back to the sketch? What? Oh, wait, 95. Okay, yeah. So we're gonna take this, we're gonna extrude it, remove, up to next. Okay, so we're gonna apply this. Then we're gonna go back to the assembly, which is going to be the top assembly. Oh wait, actually we want the wait, I know we have an oh, feeders, bro, I'm dumb. Okay, well we can calculate it from we're gonna mate this to... Yeah, it's got to be this. Oh, but it doesn't let me go to the middle of it? All right, well, it's fine. Let's try that. Flip it. Wait, here. Okay, then we need to offset it. Z probably by, I think it's gonna be a parameter, and it's gonna be the feeder, top plate to bottom feeder. Oh, but it's not. Okay, this is 0. It's gonna be in the Y direction. Okay, so that seems pretty good. Can we... There's got to be a better way than clicking this a bunch of times. Wait, but that's not right. Oh, you know what it is? It's not this. It's Wait, what am I talking about? Um or minus even that doesn't make sense. Oh, and then plus 5. Even that doesn't make any sense. What the frick? Wait, but what are we actually trying to determine here? Oh, we're trying to see. All right, let's just keep it as it is. It looks like a face. It looks like it looks like a face. Okay, well, one thing that I want to just add, because we should add it. This we can just delete, dude. Wait. Yeah, I'm a little concerned about, let's see, which one is it? Okay, first off, we absolutely need to fix the extrusion amount. Wait, we need to pick the hole placements. Why does it feel like I have way more room? The reason why it feels like I have way more room is because this is not this line does not intersect the center. Because what's actually happening is you need to take this to here. But even still, it actually does look like... Nah, we don't actually have that much room. But then we're like super height constrained if we go under this. So then we really only have like... Okay, so let's just decide on something then. Let's just, I mean, this thing should be pretty strong. So the height of this thing is borked, but I don't know why. This should be 73. It's going to be 32 plus... It's going to be 32 plus... like 41 or whatever it is. Here, we can just go to... Yeah, 41. 41 plus 32 is 73. Okay, that, yeah. So, and... But what we need is 16 plus x is equal to... Wait, then why is that... It's 50, so top plate to oh, it's a bottom flywheel, bro. Why am I so stupid? Do we have a flywheel depth? 25. Okay. Okay, now it looks closer. So if we look at now the top assembly, the mate should look weird. So it's this. And we can edit this, right? Okay, so it's okay, so right now we joined it. So it's going to be, you move it up. Okay, so it's going to be 16 plus, okay, so it's going to be perfect. But we're going to need to fix this because we're going to need to go, before we do the fillet. Oh, this is the rollback bar. Okay, we just need to do, okay, we need to put the holes in and then we need to mirror it. So we need to go to, is it this sketch? Yeah, this is our good sketch. So now we want one that's, and it's greater than, so we want, so top plate mount hole lower bound. Top plate mount hole to center lower bound. This is going to be the outer, big outer diameter over 2. And then plus a whack, but this is unwhacked. Bro, this is unwhacked. I need some water. And then the upper bound, top plate mount hole to center lower bound or upper bound. And this, I know it's like 100, but what we have to do is figure out what parameter that is. Top plate outer mounting hole distance to center. That's what. Okay, can I find where? See, that's the annoying thing is I want to know where is this being used. .106 point. Where is that coming from? Wait, is it top assembly where that's? No, it's not going to be there. It's top plate. You could always just make it wider. I don't want to do that though. It's already like okay. So we did 74. Okay, so we can do 74 again. So we're going to this. And then we're going to make another one. Then the distance from here to here is inner. Now we want to do our mirror. We're going to feature mirror. This extrusion, wait. It's got to be just those two. What? Yeah, I don't know why it's... What does this do? I don't really understand, but it seems like it fixes it. Okay, now we can do the rollback bar. Okay, so now we want to look at do we want to do an edit in context, or should we just redraw it? Edit in context or redraw it? Let's just edit in context. So we're going to take a top plate, edit in context. Okay, we're going to draw a sketch on here. Normal. Hello. Okay, then we are going to, we're going to take this and this, and we're going to use them. Oh, we don't get what we want, though. They are a little bit close for comfort, but... Well, we could just move them out a bit. We could literally just change one dimension and make it a little bit better. All right, let's just change the one dimension and see what happens. So the feeder width, but keep alt tabbing. When we look at the solenoid holder, and we look at this extrusion, yes, right. So this is going to be I have a part that I'm mounting to a top plate. The part, since it's 3D printed, has the bracket basically in the geometry of the part. So the bracket doesn't connect two parts together. One part is a bracket. But what I'm wondering is I'm trying to define a parameter and how to name it for the length of the tab of the extrusion of the part that interfaces with the part it's connecting to. So the top plate it basically touches this length of material. See if it knows what gibberish I'm putting out. Okay, we'll just call it mounting tab length. That's perfect. Feeder mounting tab length. And this is going to be, let's make it 4 times. Okay, but now we probably need to adjust, wait, this, oh crap. Oh my gosh, why is it going so slow? It must be because of the computers in the sun. Okay, and we want to move this up of this. Wow, this is going really slow. All right, let me get some water. Dude, it's totally freaking frozen. What the heck? Oh, there we go. Okay, so we just need to change this to be feeder mounting tab length. And then let's go back to solenoid holder. I'm going to delete this. Change this to. Does it re-update? That's actually, I actually don't like that it would re-update. Okay, but now if we go into the feeder, the top assembly. Oh wait, is it top plate? It's top plate that we have this context. No, not, wait, I thought we were doing in, maybe it like got out of the edit and, right, because we were doing edit in context. And then we wanted to take this, and use them. What? Oh wait, you know what I forgot? You have to do this. Can I just, well, let's use them. And then we're just going to, wait, what am I actually clicking on here? Wait, let's hide. Can we hide that thing? If we hide it all the way, does it let me? Oh, nice. No. Do I have to draw another circle? To get a face? Do I have to select it through there? That's why I wanted to do it on this side. Oh, wait. Oh. Okay. Remove up to next. Okay, now we want to take this feature and circular pattern it. We only want 2 of them. Or should we do 4? Let's do 4. And then what do we want to do? Entity is to pattern. It's not a part pattern, it's a feature pattern, and we're featuring this extrude. And the axis of pattern is this. It looks hella goofy. I think I'm going to change that to be 100. So we're going to do this. Now we have these holes, which is great, but we're going to go to the solenoid holder, and we're going to edit one of these sketches. I'm going to change this to be outer. And so now we have like kind of like a grid. So now if we look at the top assembly, we have this sort of strange pattern of holes. Wait. But why doesn't it look like they line up? Okay, wait. So what we want to do is we want to take this fastener and we want to delete it. We're going to move this thing out of here. Now we want to mate this thing with the outer inner. Yeah, this, okay, so this did not the edit in context. Yeah, dude, that's why you want to draw it, because that's totally borked up. It doesn't update the projection. You need to go to the edit in context So, okay, so what we're going to do is we're going to actually delete all of this. Or rather, we're going to... Okay, this sketch is the one. Okay, so I'm just going to take all of these and delete them. Now, we're just going to draw on here. Wait. Are we on? Yeah, okay. It's just always confusing that there's... Okay. So we are going to draw some circles. And the distance here is okay. And then do we have a line? Oh shit. It's going to be the feeder width I'm pretty sure that's actually right. Can we measure it? $74.8. Is that what we had when we were doing our calculations? Yeah, nice. Okay. I wish there was a way to easily jump to the previous tab or something like that. So wait, so in solenoid holder, we need to wait, where do we need to edit that? I think we only need to edit it here. Now we're going to take this, extrude it, remove, up to next. Honestly, I feel like I extrude more up to next than I do anything else. Than I do blind or whatever. So, we're going to do this. Then we're going to look at the top assembly. And I feel like okay, this joint broke. Oh, wait, let's do the circular pattern so that we're not, like, being weird. So now you want to circular pattern features, axis to pattern this, features to pattern this. Awesome. This is a cool looking thing. So now we want to go to the top assembly and see. Awesome. Okay, cool. So now we have that geometry and it's all parametric and we get, because you really don't want to edit in context if you can. That's why, like, if I was doing this properly, I probably would have started making the feeder by drawing the mounting holes onto the top plate and then going from there. But so now we can basically put wider things onto the top plate. And it's sort of backwards compatible with this. Okay, so let's fix this. Let's move this thing. Oh wait, let's delete this. Mate this. Oops. Okay, now we can look at the full assembly. And this is basically how do we Bro, this is cool. I'm proud of this. I like that I'm getting more systematic with these mounting holes. Or at least just like, yeah, it's interesting. So what's next though? We now need to do the mounting bracket and we're basically done. We can print the rest of the parts. Okay, so we need to activate bottom plate. And this is where things get weird because if we press P, we have all of these planes. I wonder if feature script would be a good way to do this. No, we probably don't need to do that. Okay, so let's just start with, we are going to draw a sketch on this plane. Okay, and now how do we want to do this? We want to draw what is this one? Oh. Okay, so what is that angle? Is there just a way to search parameters? I mean, it's kind of annoying because you just want to know the value of something, and it kind of takes longer than you would expect. Oh, and this UI stinks. So you just want to go here. So wait, that mounting bracket arc angle, but if we draw a line, okay. Do we get this circle? I don't think we do. So if we draw a line from here to, wait, let's okay, so that's 30 degrees. I wonder if we could change this. Let's see, does everything break if we just change this to 25? Dude, I love that when I mean, maybe it's just because I actually am doing better parametric modeling, but it really does feel like stuff doesn't break as much. Okay, so wait, what's 1 degree? It's gonna be, so first off, the circumference is gonna be 250 pi. This is circumference. And then we want to multiply that by, we want to divide that by 36. So wait, 250 pi over 36. Wait, really? Oh, wait. Yeah. So it's 2.18 degrees per, or no, millimeters per degree. So that means that if we have 5 degrees, no, we're going to have 2.5 degrees on each side. That's 4 mils of clearance. I wonder if we should define the angles relatively. So we define the outer arc angle, or we define the whole, and then we just do the math. That'd be pretty good. Because the problem basically is what I'm thinking about is if we have 2 mils per degree, and I was thinking about making, so if this is, so first off, we should just rename this variable because this variable is terrible. So this is going to be bottom plate arc angle center. So we're going to change this to be center angle between whole center. And so now let's say we're going to make a variable called millimeters per degree. And this is going to be plate diam times pi divided by 360. Okay, so now we want to calculate the angle. So we just need to divide mounting hole, or no, M6 hole divided by rim millimeters per degree. And then multiply that by 2. And then we add that to bottom mount bracket between centers. And then we get the arc distance. Okay. So now we want bottom plate mounting bracket arc angle. So this is probably what it was called earlier. And this is going to be an angle. And it's going to be M6 hole divided by rim millimeters per degree. And what is that? Okay. And then we want to multiply that by 2. And then we want to add plus or angle. These error messages are so bad. Dude, why is it frozen on me? Oh wait, no, I'm just being dumb. No, it is hella laggy though. Am I still? Yeah, I wonder how many impressions I got on this. Okay. So why does this fail? Yeah, it should be times 2 plus the angle. And it's interesting because like I'm still so novice at CAD that the like paths and decisions that I'm taking are all just intuition, but there's got to be a systematic thing of like, okay, yeah, the reason why you want to start with the parameter of the angle between the mounting holes is that that's like the bottleneck of what's, going to cause the part to either break or not break. But like just driving the right things to make a strong part is like we should totally do some simulations. I want to know well, we could just do the basic steady state finite element analysis, whatever, or something like that. Okay, let's just delete this. So it should be 2 times the M6. Well, okay, let's do this. We'll call it arc angle. Okay, I'll just say BP arc angle extra so this is an angle, and it's going to be 2 times and this is going to be called total. And this is going to be M6 hole divided by millimeter per. Right, so we need that many extra degrees. So now this should just be arc angle plus. Okay, there we go. Nice. How hard was that? So what we want to do now wait. Oh wait, did we delete that sketch? Dude, we gotta save these sketches, man. Wait, let me just check that it wasn't that. No, it's not that. Okay, yeah, so we want to sketch. Are we back? Okay, whatever. So, okay, what we want to do is, yeah, right. So what we did is we took plane 4 and we hit it, but plane 3 we want. So we're going to draw, so first we're going to take this, this, and this. We're going to click U to use it. Now we're going to draw a line, and these are construction lines, from here to the midpoint of this thing, because that's where we want to do it. And we want to draw another one. Make it a construction. Okay, great. Now we want to measure this, and it should be gray. And it's gray because it's constrained. And so 25 is correct because that's when we made the variable. So if we were to change it. So now what we want to do is we want to draw another line to the rim. And we want to set the angle between this to be extra over 2. And then we want to draw another one out here. Extra over 2. Now we want to take the arc. So wait, we're going to do an arc. Wait, we're still sketching here. Three-point arc, center point arc. Oh. Okay, and then what did we do? We just made a See, the thing is, I'm not really looking up, like, what do actual brackets look like? What would you call a bracket that has one side that is flat and the other side, basically the bracket has to wrap around something cylindrical. In my case, the radius of the cylindrical thing is quite big, but I don't think that matters. What should I just want to look up other examples of similarly designed brackets to see if I'm on the right track. What should I Google? Pipe mounting bracket. No. Okay, I get. This sort of looks like what things. Nah, bro. I don't know. Maybe people don't design parts like that, but I feel like this is a very standard part. I guess I should be more clear. I have a cylinder that's resting. Okay, a cylinder of diameter 250 millimeters, and there are holes drilled in, and its height is like 55 millimeters, and it's hollow on the inside, so it's shelled out. And then I have, but the thing is, that's the biggest print volume I have for my printer. But so what I did is I added holes to the side of the cylinder so that I can put these little tabbed things that are basically come up at a right angle, but then they wrap around the cylinder, and those have holes, and then I can use a nut and a bolt to clamp them down. and then there's holes on the face of the bracket that is going to bolt into a much larger piece, like a wood table, so that this thing will stand very still. That's some context for what part I'm talking about. It's this thing that is going to be bolted into the ground or some wood table, and then also bolts into the cylinder. Dude, I love ChatGPT so freaking much. I mean, imagine trying to Google this. Let's look up saddle mount. That could be right. Yes, sort of. Anyways, I mean, it's not like this is like whatever. It's fine. So now we're gonna take this arc. We're gonna draw a line. Okay, and now we want to. Now here's the time where we want to look at. I don't even think we added this to the full assembly ever. I don't even remember where we put this thing. Oh. And then we projected it. So what we're going to do instead is we're going to take that plane and we're going to offset the plane by wall. And that should then intersect that. Then we're going to... Oh, should we... Yeah, since we're doing a single part studio and we're just going to have different bodies, different parts in it, then we shouldn't have as much of a problem because it's not like you have to edit in context. You just have to... Yeah, because it's all using one timeline, I guess is what it's all using one feature timeline. So that's sort of why you're allowed to do it, and it doesn't cause weirdness. Because yeah, I mean, it was scary seeing that when I updated the feeder distance, the feeder mounting hole distance, that it didn't update the projection in the top plate. So that's why we redid it. Okay. So what did we do? I just want to see this sketch, I guess. So this being okay. So what, dude? It's so funny. You just start thinking in constraints. Oh man, it's so interesting. But we might not actually be able to do. Oh wait, will we have vertical constraints or is it? No, yeah, we will. So if I draw a line like this, and I make this 30, this is fully constrained. Nope. Oh, and we have that plane geometry acting as a line. That's actually pretty cool. Oh. Wait a minute. I think we want to do it. I think we want to do the other way. Wait. Wait. Structural or decorative? I mean, it's kind of like a way of approximating a fillet. I never thought about that. But yeah, so just... Okay. I kind of want to know what the strongest place to... Because, like, should I put this in the middle here? It's probably best in the middle. But wait, why? I don't know why, but I feel like it is. Okay, so let's figure out. So I want to undo that sketch because I don't think that this is really what I wanted to do. I think what I wanted to do was I want to draw an arc. Or wait, no. I want to change. Okay, so first off, all right, let's just do this. No, see, okay, right. So this line is no good. What we're gonna do is we're gonna make a center point arc again. We're gonna click on the center, and then we're gonna click on this, and we're gonna click on this. Oh, geez. Sketch could not be solved. Is that because of the 5? Okay, well, if that's fully constrained, then that's great. We are going to extrude this by... first off, it's a new part. And this is going to be flipped around. That's weird, but that's fine. Okay, this is going to be the height of bottom plate height. Easy, bro. I'm full of parameters. Look at that. That's not enough. What are we talking about, guys? This isn't right. Oh, it's because of the straight line. Okay, so that's correct. But what is this? Oh, that? Wait, I think I just want to delete that. Okay. Wait, is this thickness not... Wait, this is... Oh, damn, bro. I'm so dumb. For real, I'm damn. What am I doing? This is only... Yeah, I thought that was thin. I pulled this thing out. I printed this. I mean, I actually think it's... I don't know. I guess it's not that strong. Yeah, I printed this out and I was like, oh. Anyways, you can get as parametric as you like, but if you're a dumbass like me, then it doesn't matter. This print took like 4 hours too. That's so silly. Because I made the radii. Oh, that's such a classic one. I'm like, why does this look so much bigger than this? Jeez Louise, man. Okay, so I'm gonna take this and I want to oh wait, I want to take this sketch actually. Do we have the lines? We don't have the lines. I'm gonna make this come out. Okay, so we're gonna say the bottom. Okay, I'm just gonna. I don't have a good naming schema, but so we're gonna say the BP mounting bracket bottom length. We're gonna say that's 40. Should we also make this curved? That looks small. $66. This one was 80. Let's just add a few degrees. Let's just pad the degrees. So that extra angle thing. $72. I could do it a little bit more. That's good enough. Okay, so now what we want to do is we want to do plane. Oops. Alt C plane. Oop, what the hell? P, Alt C, plane. And we want to take this plane, offset it by wall. Okay. Now we want to sketch. Okay, now we want to hide plane 4. Can we hide plane 3? Wait, 3. Wait, no, not plane 3. Or yeah, plane. Wait, plane. Yeah. We can hide plane 3. What we want to hide is plane 2. And we want to draw a sketch on here. And we want to hide this bracket, and we want to project this, and we want to use them. Now we are just going to extrude them, remove, up to next. What? Oh, is this that weird thing? Yeah, this doesn't work. Right, up to next doesn't work on this. Look at how close that is still. Did we... Bro, there's just one type of fly that comes around here that's just like so annoying. Okay, wait. So let's do this. 5.1. Now we want to just check if we change this. Okay, that's better. But don't we kind of want it a little bit more in? Five extra degrees on each side. Wait. What was it? It was like 2.8, right? On each side. Yeah, I don't know why that didn't really work out like we wanted it to. I'm gonna increase it by even more. And I'm just gonna delete the this being parametric. And we're just gonna make this 15. Okay, so now we just need a circular pattern this. So and it's gonna be this extrusion. Oh wait, features. I always forget that. This extrusion around this. Oh wait. Do you do 1 or 2? And it's gonna be oh no. It's not over 2. How did I do this the first time? Wait, extrude 1. Wait. The feature that we're patterning is this. There we go. And they're tangent, bro. And now we just can circular pattern this part around this axis. And we can make 4 of them. Why don't we just make 4 of them since we added all the holes? Sick. Now let's go to the full assembly. Wait, what? Why didn't it recompute? That's confusing. Bottom assembly should have my brackets. My brackets, my brackets. Have you seen them? What the heck? So, I don't understand. Did I just refresh it, maybe? I feel like that's not going to do anything. Bro, look at all my variables, bro. I'm rich in variables. Okay. So, we all see those brackets. But then you go to bottom assembly. Do you have to, like, update? I wonder if you can fold these into a group or something. Circular pattern parts, then you just get a billion parts. Should I do a little test? So the test would be, I'm going to make a new document. I'm going to make a box. And a cylinder. So these are going to both be their own part studios. Then we're going to make an assembly file. Okay, cool. So let me just test that out because I don't really know what's going on. Update test. So basically what we're saying is here we're going to name this box. And we're going to make a sketch on here. How many is it? Hold on. If I do Shift E, 1, 2, 3. Okay. Now I'm going to make a new part studio, and this is going to be the cylinder. Okay. Okay. Now we are going to insert both of these. So we're going to move this. We're going to join or mate. Geez, mate this to that, and then we just need to flip it. Okay, so now we put this thing on top of this thing. But now I want to draw a sketch on here. What? Wait. I'm so confused. All right, wait, let's do a... Okay, so now we have a new part. Now we go to this assembly, and it's not there. All right. So, okay. So, wait, but we only inserted a part? When we do... Oh, really? So I just did a little test, and I had an assembly file, but then I went back to one of the things that it had in it. So one of the part studios that was inside the assembly. By the way, this is in the CAD software onshape. And in the part studio, I made an edit where I added some new parts. But then I went back to the assembly file, and they're not in the assembly anymore. I see that if I go to re-add that part studio, then the new part shows up. But is there a way to just like update? Dude, transcription plus GPT is so nice. You can just ask your question how you want to ask it. You can update your assembly to reflect changes made in the part studio without having to re-add it manually. When you a yellow triangle in the assembly tab next to the part studio in assembly tree. But is this just a part? Okay, what is insert? Okay, what if I did this? Should I just look up updating assemblies? Drawings. I don't want drawings. Bro, these aren't nothing looks like what I'm looking for. Okay, what if we just try... Oh, but you can only go part for part. You can't go part for... I don't know what you call a part studio top level thing. Yeah, so it says select replacement component. Bro, what? Do I need to add them? Oh, there's actually such a thing as oh. That's probably nice. That's what we should do. Nope. Right, but then you have to do all of it over again. But then there's also 2 of everything. Should I just... Oh, maybe I could just do this. Wait. Insert... No. Insert... Okay, so that's the way you're supposed to do it. And then you have to do all the joints. Yeah, so I'm actually gonna... Okay, so here's a good... Okay, so we're gonna cancel this again. We're gonna insert one of them. Okay, now we're gonna add the joint, and I'm curious to see what happens here. Or the mate. I don't know why they don't call it a joint, but they call it a mate. Good day, mate. Okay, this is driving me insane. I don't know what I'm looking at here. So I'm gonna hide this part, and then we're gonna go to... Oh, it's not gonna know this. Because I did it so weirdly, it doesn't really know what's going on here, right? Oh wait, does it? There it is. What was it? Oh, I saw it. There we go. So it's that. Then we're going to hide this and turn on this. And then we are going to put it right there. Wait. That. We hide this. Let me turn this on. And we just want to put it right. Let's just... Oh, wait. Yeah, let's just offset it by Z. By, what? 2.5. No. Not 2. Like 1.25, right? Is it in there? Is it in the inside? I don't think so. I think it's good. So now we want to try this circular pattern thing. We want to pattern this. And we want to do it on... and we want 4 of them. I like that you have to specifically press enter for it to recompute. Then it doesn't feel like it's like lagging, because it could very well be a slow operation. Oh, dude, I gotta go soon. Bro, I gotta get this stuff printed. Oh, geez, Louise. Okay. So, actually, I have like 2 more hours, but I think I need to eat. So when we do this, oh, that's so nice. Then oh, that's so nice. But these aren't jointed, right? I guess they are jointed, but... Okay, but this... Wait, so if I take this part, I can't move it. But it's not jointed? I don't really know what they're doing there. But anyways, so now if we go to full assembly, it's still not going to be there, or it will be. Okay, so if you... Okay. Right. That actually makes sense, though. Sort of. So this is done. This has both parts that I wanted, right? Let's see. Today I had feeder, solenoid, mounting bracket, hopper, fasteners, and then stuff about the Pico. So, I'm ready to go get some parts off the printer and then just print some of this stuff. Okay, I'll be back. Oh, you gotta be kidding, man. I think I just need a. I mean, I could take it apart again, or I guess I could replace it with a 0.2, but I can't have every 1 in 5 prints fail. Every 1 in 4 prints fail. It's just too high of a fail. So, anyways, we got a bamboo. No, not list. What are we talking about? We're talking about. So the pillars seem fine. The gear seems fine. The flywheels seem fine. It's just that what was it? Motor mount. I wonder what caused this thing to fail. Okay, so now we need to export solenoid holder. There's no just. Wait, bro. Lol. Oh, but no, we should just do it from. We should just do it on this face. Oh, and I forgot actually. I wanted to add. Wait, we forgot a bunch of stuff, dude. What am I talking about? Look at this. Where are the holes on here? Oi, oi, oi. Wait, so I actually want to delete this circular pattern though. And this one. What is this one? Oh no, that one you need. This one you don't. Okay. So wait, what were we just doing? Okay, we added the thing. All right. Wait, what? Wait, can we do this? Or not X, Q. There's a circle here. This is gonna be the feeder mount. Wait, total. Is there a total angle? Okay, oh, it's this. Bracket arc angle. It's, okay, what is this gonna be? Okay, so you have this arc here, and this is 40 degrees. And then you have this midpoint line, so then this subarc is 20 degrees. And now you want it to be 10 degrees. Okay, so you want it to be over 4. Bottom plate mounting bracket arc angle over 4. Yeah, times the number of... Oh, wait, so this is in degrees. Oh, wait. What? Bro, and I hate that this thing is like the smallest. What if I just did 10 times this? Because I know that. But that sucks. Also, okay. Wait, no, but I really don't like that. All right, whatever. Because I really don't know what to do about it. So, okay. Okay, that was a close call. So now, hopefully, that'll update. So if we look at the full assembly, we have holes, which is good. And then what we need is... Dude, is this a graph coloring problem? Yeah, it is, because the edges are intersections. That's so funny. I never thought about this, but you have a... Yeah, you have a graph coloring problem here where you need to... Dude, that's so funny. Okay, this is a reminder for me. I should do a thing where I make a feature script thing that tries to invoke that, and then we time it and see if it's actually like whatever MP complete. But that'd be so funny to like blow up this thing by trying to make it solve SAT problems. Dude, that's so funny. Using onshape as my SAT solver or something. Okay. But there was two things that I did. I wish there was like a timeline of just everything that I did. So like it concatenated and sorted all of the actions, because what was I working on? I was working on the bottom plate, but then I was also working on the I feel like there was something I forgot. Oh yeah, this thing. We didn't put this in. Oh, also wait, but I wanted to do something fun. A fillet. A nice little fillet. Oh wait, and then this 3D printer thing. Oh, dude, this is such a bummer, man. I'm so tired of this thing being messed up. Okay. So now I think we're ready to take this. We're going to rename this as okay, now we should be able to export this thing. Wait, but we didn't actually ever put any... Maybe I should wait to print this, because I feel like I want to work on the hopper. I mean, it is kind of annoying that the past, well, today and yesterday, have just been redoing work. But the idea was make these walls thicker. Oh yeah, we should definitely add a fillet here. I really like that you don't have to hold control down. Fillets are beautiful, man. I get why everyone fillets basically everything. Oh, it's for strength, but it's for beauty too. There's something so nice about a fillet, man. What the hell? Oh, you appreciate design so much more when you have to think about uh, arcs and stuff. I wonder if I would just go in. See what happens if I extrude this. Sort of close. But now I kind of could get a... What, I mean, what am I even imagining, you know? It's funny because I feel like I'm making a gamble, but also it's because it feels tacked on. So you really need to go back to where the change needs to happen, which is before that's the fillet. The fillets always come at the end. That's actually now what I'm learning is fillets are not structural. So wait, if we did this, wait, cancel this. We did um oh wait. Oh wait, no way. Really? Still? And then we wait, no, it's still bad. What does this mean? What if we just delete it? Oh shoot. Show overdefined, show expressions, show constraints. Wait, what if I just delete this and do it again? Actually, I like that it didn't take me normal. This was a case where I liked that it didn't take me normal. Wait, what is this? Oh, but it would need to be more significant too. Right. Just delete this. So now this is 60. Oh, see, that's the problem is it's so easy to forget that you did make a parameter for something. So even though you oh yeah, because I probably have some weird reliance on 2 times wall plus solenoid width. Yeah, it would be so cool if you could just search up. Oh, that'd be so sick. Yeah, so you just take all of the expressions and you do a pattern match for if this sub-expression exists. That's why you need a canonical ordering. I never did canonical ordering in cast. Actually, that's probably one of the features that I really should add. Let me put that in my notes. Where's my script? Oh wait, no, it's in Google Docs. All right, I'll do it later. But yeah, for real, because basically I want to know. Okay, yeah, dude, that's definitely something on my to-do list. Build a little pattern matcher for onshape. It searches through all the expressions and finds all the usages of 2 times wall times solenoid width. Because whatever is using that is probably not accounting for this new stupid extrusion feature that I added. Which honestly, it's more of like, I mean, it's still a really cool feature and it's useful, but it doesn't get over the fact that what I'm doing is bad design. That's, I guess, what's really going on. Okay, the whole point of this is so that I could put mounting holes here, 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 and here. So that means we need to redo the fillet. Okay, so now that we have this, let's look at the full assembly and see there's probably an intersection. Oh, it's actually still not touching. Wait, but why is that? Oh, no, that's blue for good reason. Okay, so they are lined up still. And so now we want to put a hopper on this thing. I need to charge my phone. I wonder if Bamboo's gonna come out with an SLA. How much does the Form 4 cost? Blazing speeds? Do you have to throw out all unused or not? Bro, I really want to form. $5,000 though. There's no way I can justify that. But that would be so sick, man. Wait, the Form 4 is 5 times faster than the Form 3? Do you have to do more supports? It seems like every part that I see with SLA has a ton of parts. Oh, this is so cool, man. Wait, but do you dissolve them? No, right? You have to clip them off. Yeah, see, that's probably why Shane has an SLS machine. He can't be bothered with that. Oh. It is really crazy that everything around you has been designed, man. The world has just been designed by engineers over freaking millions of man hours. Actually, it's crazy to think about. If everyone spent an hour doing something, that's 8 billion man hours. That's just crazy to think about. What the fuck? 8 billion hours doesn't even make sense. Yeah, I just locked in real quick for 8 billion hours. Okay, what are we doing here? Are we almost done? Ready to print? The problem is I'm kind of scared, right? Like, wait, that's too fast. This feels slow though. All right, so I think I think I'm gonna add holes. And uh oh dude, I'm actually dumb because um the big advantage of the threaded inserts is you get first off because it makes it so much easier to remove because you don't have to it's definitely weaker, but you don't have to freaking hold the nut under the top plate. Yeah, me making everything M6 was actually a really bad idea. I don't know why I defaulted to M6. Because there's no way I have M6 threaded inserts. That's ridiculous. I'm gonna go check though. Okay, so I actually do have M6 threaded inserts. I think I'm gonna try these out. The only question is gonna be M6 by so what is the biggest OD here? Because the thing is those are all with clearance. They're all what 6.2? Oh wait. Ah. Wait, does that work? That's cool. Wait, what's going on here? Oh wait, we made this as its own thing. So we're gonna actually feeder assembly solenoid holder. Wait, but let's just see what M6 hole is. It's 6.2. Wait, should I try this? But the thing is, this is how thick? This is 8 thick, but the top plate is only 5 mils thick. Oh shit, you know what? The depth of the top plate is bound to wall. Wow. This is 8 thick, so like most of this is gonna be sticking out. Honestly, I'm still kind of down to try it, at least once. Okay, but is now the best time to experiment with this? Okay. I'll ask ChatGPT what it says. I have some M6 by 8 by 8 threaded inserts. What does the other 8 mean? I think it means it's the outer diameter of the insert itself, but the inner diameter is probably the 6. Yeah, that's what it means, for sure. Duh. Okay, but okay, if I'm doing PLA with like a 15% infill, how big should I make the hole? Because I'm going to use a soldering iron to get the brass hot so that it sinks in, or at least that's what I've seen online. So, how big should I make the hole that I'm inserting the threaded insert into it be? Interesting. Okay, so what we're going to do is we're going to make a parameter. Sort of this, it's like the first thing in Fusion they say start off with a sketch. Here you start off with defining some variables. Insert. Now we're feature complete. We should not have to open Fusion almost ever again. I'm so sad that this print failed. God. Golly, bro. Oops. Okay, hopefully that's going to speed up my computer a little bit. This is probably taking a good amount of percentage. I mean, it says it's not. Maybe it's just maybe it's just the program itself is too slow. So this is going to be It's gonna be okay. So now we're gonna go to I'm gonna draw a sketch on here. Are we in a sketch? No. Oh, what? That's fine. It doesn't really matter. We want one like actually, huh. Wait. If we draw it's gonna be 1 mil. But we don't have to use M6. We should just use M3. 4 M3s is pretty strong. Well, I'm guessing. So let's see, what else do we have in this kit? Let's do M3 by 8 by 5. This is gonna be oh wait. I'm so bad, bro. These. This is gonna be 4.8. Okay. So wait, let's just look and see what a that's like way more reasonable. And especially if you think about it in terms of the ratio, because then it's like almost it's like it's a lot closer than what you want than what it would be. Oh. Is this still okay? Yeah. Fine. Do we want one more? 4 is enough. What the heck am I talking about? Wait, why isn't this? Oh. Oh wait. Does that make everything? Oh no. Okay. This is gonna be it's by 8, right? M oh shoot. M3 by 8 by 5. And they give you 40 pieces of that. Okay. It's kind of a gamble, but I mean, not really. It's just a time. It's a gamble on time because like if this doesn't work out, then you have to reprint again. All right, so yeah, it's 8. So let's just make it 8. Okay, so now we're sort of ready to print. We haven't designed anything, but at least we've made the part extensible. Now it's just up to us to actually put the hopper on there. Dude, it's funny, like all the like old designers, like I just saw this thing on Hacker News. I think it was like a Dieter Rams iPhone, like inspired iPhone holder. It's just so funny to like imagine it's just like you're so distinctive because you made a fillet radius hella big or something. But I don't know. It's like they did all this by hand and they just conceptualized of it. But now that you have tools, you can just play around with it and see what you like. And oh man. Ugh. Okay, so let's just freaking do it then. Okay, so we're gonna save this part. Okay, what do we need? We have the bottom plate, the flywheels, the pillars. Okay, wait. Let me just write down all the parts that we need. We should be able to go through this full assembly thing. Two BP mounting brackets. Dude, what time is it? Okay, I have like an hour. Two flywheels. One yaw only motor holder. Now, one solenoid holder. Four pillars. One small gear. One big gear. The top plate. One top plate. One bottom plate. Okay, so what do I have printed? I have the pillars, I have the bottom plate, I have the small gear, and then I have the flywheels. Great. So now we want to just open up a bottom plate, take this, export it. I don't know if we already did that. Oh yeah, we do. I'm going to overwrite it. Okay, so let's just add what we need. Are we waiting? No, we're not waiting to print this. We need that. We need solenoid holder. And then yeah, and then the big gear. Oh wait, should I? Let's see. I already printed the bottom plate. I don't have the top plate yet. I'm trying to think. Maybe it would be really nice to change over because that hub is deep. So we could put some M6 by 10 threaded inserts in there. M6 by 10 by 10 or whatever. M6 by 10 by 8. Which one is which? It's probably it's probably the height and then the OD. Yeah, it's the height then the outer diameter. Okay, so let me just go look because that would be really hype. Because okay, if I just sit down and write out how to if we just write down how to assemble this thing, it's actually harder than you think. It's like way too many steps. Okay, assembly. I'm just gonna write it out. Or let's do it on paper. It's okay, whatever. Okay, so let's just write down parts. 2 bottom plate mounting brackets. 2 flywheels. 1 motor mount. 1 solenoid holder. 4 pillars. 1 small gear. 1 big gear. Bear? Where? 1 top plate. 1 bottom plate. Okay. First, use self-tapping. Oh, I don't know if we could get away with it, but that would actually be, dude, threaded inserts. I might become a big fan of threaded inserts. First, use self-tapping to put the 4 pillars in. That's easy. Let's just number it. Yeah, the allure of not having to put a nut on it is really freaking high because it is so annoying to having to keep disassembling and whatever, and so anything to make that better is actually really nice. Okay, so then that's it for the bottom plate. Now, wait, what? Dude, is it doing this again for real? Okay, there we go. Okay. Let's just put the motors together. What are they called? I just D3536. Okay, then what's next? Oops. Oh, this is probably the best place for threaded inserts, dude. Especially because those have to be 7 thick. Oh, are we goated? Oh my goodness. Should I do that? There's a wall measurement in there that all we'd have to do is change that from a 5 to an 8. And we'd use well, we don't have that many M6. We have a good number of M5s. We have 10 M5 things. Wait, no, but we have to use M3s for there. Oh my gosh. So wait. Um yeah, update motor mount to use threaded inserts. This is so big. I wonder how hard it would be for real. I think it'd be super easy. Okay, wait. So let's just remember. Wait. Actually, that's probably the one place you can't really get away with it. But I don't know how to. I think what I'm going to do is and maybe I'll do some test prints where I can actually test just by feeling how strong they really are. Because I don't think I can. Yeah, just thinking about how fast these things turn, I imagine that and the weakness of PLA and creep and all that, that these threaded inserts are not going to cut it. So we can't do this. It's a nice idea, though, because it would really simplify the assembly. Dude, this looks so cool. Yeah, I designed that shit. Put the DLCs together with flywheels and the mounting bracket on. Use what I forget what size they are. Use nuts and bolts to tightly clamp the motors down to the yaw only, or the motor mount. Use uh screw in the big gear to the top plate. Wait, why are we only looking at this? Okay. I wonder if I... Oh, it doesn't change them. That's so annoying. Whatever. I'm just going to do this. Okay. So now the Nemo's in. Okay. Then I guess you might as well just do this too. Put the small gear on the shaft and use set screws to fasten. Set screws and nut. They're actually set bolts, but whatever. Well, I don't know. So now 4 pillars are in. The motor is in. The gear is there. The brackets on the side are there. Top plate there. Okay, now tightly clamp down the motors to the motor mount. Or actually, before you do that, nuts and bolts to tighten down the solenoid feeder assembly to the top plate. Then actually, dude, wow. These threaded inserts, if I make the top plate 8 mils. Okay, here's my question. If I use strong nuts and bolts to get this down, but also these are still going to be a pain in the ass to install. But then I have to reprint the flywheels. Yeah, you got to think about installation in the design. It's so hard to think about. But okay, so my question is, if I used strong nuts and bolts to really clamp down the motor to this mounting plate, could I maybe get away with using threaded inserts on the top plate, or does that also need to be really strong? Because the advantage of that is then we're not bound by this 100 millimeters, these pillars anymore. We're like smooth sailing. We could go to the very edge, which means that we have a bigger work platform. I mean, it means we could put bigger stuff in the pan tilt. Does it? I actually don't know if it does. All right, nuts and bolts to tighten down the motor mount to the top plate. Oh wait, no. You don't do that first. First you Oh wait. How do you install this thing? That sucks. Yeah, this is the place that I really want to use threaded inserts for. What are those, 6? I could use an yeah, I could try to use an 5 by 6 by 7 there without changing the design. I might do that. Because otherwise, okay, so here's okay, without threaded inserts, you now need to get the it's easiest to now fasten the motor mount to the top plate, but the top plate or the motor mount is not high enough to get the center bolt in. The bolt that keeps the top and bottom plane. Is it called axially? But now the motor mount is not high enough. So you need to put the bolt in from the bottom, then the nuts on top. That's probably the better way to do it. Oh. Now screw in the big gear to the top plate, and then you put the center thing up, and then you do that. Okay, so that's pretty much the assembly. That we can just delete. Okay. Okay. Oh. Ay, ay, ay. Okay, so are we printing or not? Basically, the question is. Okay. So let's just see where we're at here. I thought I added some stuff. Did we cancel that? Okay, so the brackets. Motor mount. Big gear. Okay, wait. So wait, but we're changing this to use threaded inserts, right? Okay, let's freaking do it. The hesitation comes from not wanting to go back and break things, but you just got to get over that. So this is going to be part of the top plate. So we're going to go to top plate. Now we're going to click on this and we're going to see where so we made this gear first. So this is it. Okay. Okay, so this, we are actually going to make, wait, M4? We just decided that? Okay, so let's just change that. The problem is we have different M4. No, we don't. They're all just by 6. So we want this to be 5.8. Wait, actually, can we do I'll just say inverse clearance. Dude, this parser sucks. Bro, I'm so sick of this. Why are you like this? So we're gonna and then what's the size above? So we need to change the top plate itself. Wait, what? So they're M4 by 8 by 6. That's what we're going to use. But we're going to roll back to there. And we are going to use this sketch, take these two, move. Or 8. Now, why is that 5.8? Oh, did we do a project? So wait, so we need to change the top plate because we want that to be M4 hole, not projected. So now we need to look at, or we need to take this feature and we need to find it. Was it this? But what we are going to do is we're going to turn off the top plate. Wait, we're going to turn on the top plate. I'm going to draw a sketch on here. I'm going to hide the top plate. I'm going to click on these and we're going to use them. And we're going to turn back on the top plate. And we're going to make this and we're going to make it and same with this. Cool. Hopefully it's strong enough. Okay, so now we need to re-export both the top plate and the spur gear. What? Okay, that seems like what we're going to be able to do. Okay. So I think we're ready to print. So wait, in the assembly now. M4 by 8 by 6 threaded inserts. Ugh, so stupid. Yeah. Oh man, I really hope my design works. I really hope this works, man. Man, I really hope this works. I mean, so now we can just sort of get to work designing the hopper, but I kind of need to do... All right, maybe this is a good place to end the stream because I need to make food and stuff and leave. I like this top plate with all the holes. I bet a real designer would look at this in horror. In horror. But I don't know why they would. Like, mainly it's that the holes are defined based on a radial dimension as opposed to like a horizontal vertical pair. So it makes all the numbers that come out of the like horizontal distances from, you know, kind of weird. All right. That's it then. I guess let's see, what else did we want to get done? There's only 2 places that we added threaded inserts for, I think. Oh yeah, fasteners. Okay, so we did. So I guess later we'll do the hopper and the fasteners. The hopper is going to be interesting because I feel like you don't want it to stall, but you also don't want to have too much high torque because then it's just going to snap everything. I don't know how best to agitate the balls. Okay. Pretty good stream.